Alright, so graphing a parabola. In order to graph a parabola, you have to first have it in standard form. So you're going to take this original equation here and you're going to put it into ax squared plus bx plus c. So basically all you need to do, get y by itself, move all these other ones over. So the positive 2x squared becomes a negative 2x squared. The negative 4x becomes positive 4x, and the negative 6 becomes positive 6. Now, after you have this in standard form, y by itself on the left, first thing I want you to do, find axis of symmetry, negative b over 2a. There is your b value right there. So switch the sign on it. So now negative 4 divided by 2 times negative 2, which is your a, that negative 2 right there. Negative 4 divided by 2 times negative 2, which is negative 4. Negative 4 divided by negative 4 will give you 1. Now, what did we just find? We found the axis of symmetry is a line, x equals 1. We've also found the x value of the vertex, because if you remember, the vertex is on the axis of symmetry, and the x value is that of the axis of symmetry. So, there we go. Now, how do we find the y value of the vertex? Well, we take that same function, and we're going to plug the x value of the vertex in here, because this is set y equals. We plug it in, we will get our y value of the vertex out. So plugging in 1 for all of my x values doesn't really change anything. Just want to show it to you. 1 squared is still 1, so doesn't really change anything. But just for the sake of argument, negative 2 plus 4 plus 6 will give you positive 8. So our vertex is at 1, 8. I will go ahead and plot it. I'll go over 1, up 8, make a little dot. You can also note the axis of symmetry as a dashed vertical line right through x equals 1. That's not too terrible. So, there you go. Now, next thing, easy to identify, y-intercept. You just go over, look at your function, and identify c. c is always your y-intercept. No variable on it, so y-intercept is at 0, 6. I will go ahead and plot that. The next two things I want you to do, and in class you might have heard me say plot your next two found points, is I want you to look at where your axis of symmetry lies, right here on 1. And I want you to move towards the y-intercept, so we're to the right of the y-intercept, so I'm going to start moving left. If I go 1 to the left towards the y-intercept, I'm actually on the y-intercept. There's no reason to find it again. If we plug 0 into function, we get 6 out. We already know that. So I'm going to move 2 more to the left. Negative 1, and then negative 2. If I plug those two values into my function, I will get 2 additional points, which we can then graph. Again, I start at the axis of symmetry, and I move towards the y-intercept, and get the next 2 available x values. So I'll show you plugging these in. If you wanted to, certainly use a calculator at this point. That would be fine. But again, you just have to show exactly where you're getting these from. So negative 1 squared, still 1, doesn't change anything. 4 times negative 1. So what does this give you? Negative 6 plus 6 gives you 0. So my next found point is at negative 1, 0. I'll go ahead and plot that. Nice and neat right there. Neatish anyway. And now I will plug in negative 2. So negative 2 squared plus 4 times negative 2 plus 6. If we go through this, negative 2 squared is positive 4 times negative 2 is negative 8. 4 times negative 2 is negative 8. That's negative 16. We may be off the graph, but let's just finish this off anyway. Negative 16 plus 6 is negative... Oh, nope, still on the graph. Alright, so I will go over to negative 2, down to negative 10, and I will plot it. Now, you have half a parabola here. You have your axis of symmetry, you have your y-intercept, you have your 2 found points. But using this axis of symmetry, using reflections, we can get the rest of our parabola pretty easily. Go up to the axis of symmetry and identify your other points. If I look in the axis of symmetry, this point is 1 to the left, so I need to graph 1 to the right. Let's put a little dot there. Looking further down, this one is 1, 2 to the left of the axis of symmetry. Let me count that again. 1, 2. So I need to go 1, 2 to the right and plot a dot. Let's see, next point is down here. That is 1, 2, 3 to the left. So I need to go 1, 2, 3. 1, 2, 3 to the right. And then I'm going to do my best to connect this with a smooth curve, which I doubt I'll be able to do. But, yeah, not too terrible. And there we go. We have graphed a parabola, pretty much. All right.